after this distributed computing, which has divided into small segment of computing, which parallelly executing, which has increased our performance as well as which has also reduced the time because the parallel computation has reduced the time. Then another application was fifth utility computing was offered. In utility, especially based on application, so offering computing resource as a meter service. Okay, so suppose the electricity meters are there, in which case you are offering like as a meter service, you are charging money also. Nowadays vendor providing the cloud also, charge basis, hourly basis, yearly basis, monthly basis, they are providing you the computing. So they are offering computing resource as a meter service. So how meter used to work, similarly we are offering this utility base. You particular time you want to execute, you can execute, later on will allow someone else to execute that portion of the computing power, computing resource. So computing resource, you have a computer system, you have processor, you have memory power, you have storage, you have all sort of things. Okay. Then the very important SOS, software as a service, was evolves, in which what you can do, you can upload your computing code over some machine, and machine will process and analyze, and then finally it will give the output. So network based subscription to application, where we can provide the particular, you can pay money and some network service will be provided you. Okay, as a software service we are providing you, and you can execute your code, you can analyze, and you can, till when you are required, you can execute this. Then in 2009 the cloud computing was here, that is like centralized computing, huge processor or computing resource you have that is available on cloud. So you can hire the service of cloud. Different vendors, local vendors are available nearby you, from where you can contact. You can get like Microsoft Azure, IBM also has its own cloud services. So anytime, anywhere, access to resource, deliver on the demand on the service. Whenever you require, you can access from the cloud the data. You can upload data there. You can download data from there. You can perform your computation. You can perform your analysis. Am I audible to everyone? Hmm.
Yes, sir.
Yeah, okay, perfect. So I think that this is clear to everyone what I have
Sir,
discussed. Yeah,
Vijay sir,
yeah.
the sound of message is coming, sir. I don't know by your side or by other side. I don't know कि WhatsApp की आवाज आ रही है सर कहीं से ना
अच्छा, from my side,
नोटिफिकेशन की
WhatsApp.
आवाज काइंडली क्लोज दैट सर
That I closed, है ना?
हाँ हाँ थैंक
So now it is okay. Now I have closed that one. So now the sound is perfect. Okay, it is coming from some other side. I request you to organize a kindly mute other, है ना? उनको some other place I am receiving this. So okay. So I was
the participant
just.
kindly mute yourself.
So I was discussing about different type of computing, trend of computing, how it is evolved from 1990 to 2009 on, recently 2021. The next area is fog computing. Okay. So from distributed computing, when we have divided the computing into different computer process and all sort of things. Then we went for this utility based computing, where particular utility you can take as a service like meter you use to have, and then you can pay money for that much amount of time on computer, and later on someone else will use. Like maybe you understand, like you are bringing the CD-ROM, you are taking printer, then someone else will use that computer, and then software as a service, in which we are providing. Earlier we have concept to hardware to provide the service. So now what we are doing, we are providing as a software as a service. So, quarterly basis, monthly basis, yearly basis, day basis, hourly basis. You can get the network service subscription for a particular time, and you can avail the facilities. Then 2009, the cloud computing was there. So it is like a centralized computing, where you can upload your code. You can get the cloud has particular service related application will analyze that particular code, will give you result, and will provide in such a medium which can be utilized by others. Okay. So like suppose you are visiting to doctor, you have taken your blood samples and others, it is available in the cloud. Now anywhere you visit, doctor can access this one through cloud. So privacy and other issues we can maintain, but the thing is that when you are uploading your data over cloud, see the cloud is generally very far. Sound is coming. Okay. So cloud is just not to upload the data, to download the data. It is some they have their inbuilt software by which you can analyze, you can get certain things. Okay, now next I'm going on. Already you are aware of cloud computing. Already I discussed, but today the topic is fog computing. Okay, so let us try to understand the difference between cloud computing and fog computing. In fog computing, especially what is happening, you are not performing your computation on the centralized cloud. Instead of you are designing a small local hub on which you are performing your computation. Suppose this is your cloud, and now cloud is not directly accessed. You have different local as devices, as networks by which you are performing your local computation. And until unless there is no requirement of cloud, you are just performing some computation. So cloud is work. These edge devices is working as a gateway. Okay, so these are considered as a fog, as fog is near to Earth compared to the cloud. So same concept was higher here. So that's why the end. But let us consider the cloud computing first, then come on the fog computing. We have dedicated resources for computing as well as computing. Later on, we'll see that how edge computing is supported by the fog computing. So a cloud refers to the distinct site invoice that is designed for the purpose of remotely provision of scalable and major IT resources. So generally, what is there? You can see that diagrams here. Some servers available on the clouds. People are uploading their data, downloading their data, doing processing, and all sort of things we are doing in the cloud. So there is one centralized system, which is my request. Kindly mute yourself.
Sir, I'm Sanjay Raghav. Sir, I have
Please,
muted it.
hmm, I request, it is disturbing lot. So it is request to participant kindly maintain the decorum. Discipline also required. Then only will run the resources. Otherwise, no use. So it means the providing the remote service. Okay, cloud is the centralized system. You are at my end. You are accessing the particular service. Suppose you have to upload your code which you have written, all your software modules, your app you have to store somewhere. So it is through cloud only you are accessing everything. So cloud is providing its own security, its own benefits, its own availability, its own protocol set of things. We'll see that as pass and SAS will check the cloud service after this. In short, the cloud computing is type of internet-based computing where different services such as server, storage, and application are developed. So you have server where you can store, where you can process the computing. You have storage where you can store the data for future use, and you have the particular application to analysis purpose or something you can access. Okay, so like you are storing your Aadhaar card detail on the cloud, so everywhere you can access whenever um, documents, vehicle documents, all are registered here. Okay, through internet you are able to. So it's a distributed technology which deliver host service over the internet to provide easy access, scalable number of application you can develop, provide services. Okay. So the five characteristics of cloud computing is an on-demand service. So you have particular whenever you require water supply or your um, gas bills, your trunk calls, your messages. So a consumer can one directionally provision computing capabilities such as server time and network storage are needed automatically without requiring human interaction with each service. Whenever you are accessing through particular app, your detail are going to be get download. So these are the on-demand services. Okay, one dice. Second is broad network access. Okay, so capability is available via the network and access through standard mechanisms. So we are providing the like computing powers. We have chunk of SCADA server and other things. So heterogeneous kind of computing is there, and then the different clients are there. Some are accessing from computers, some are accessing from mobile phones, some are accessing from the tab. Different utilities there. So that means broader network access. We are providing to different network capabilities devices to access my data. These are the services which cloud is providing. Resource pooling. This is the important concern. We have heard about carpooling where multiple people are sitting in the car so that the resource cannot be wasted. So you can see that this is resource utilization. The providers computing resources are pooled to the server multiple consumer. Okay, so when I'm using for 1 hour, I will use, then some processor will be utilized by the some other, yes, some hard disk will be utilized by someone else to utilize their data to store their data. So multi-tenants, एक से ज़्यादा किराएदार. Okay, so you have multiple consumers which are consuming these things, and in this way you have resource pooling. Some resource will be utilized with different physical and the virtual resource type. Okay, assigning and assigning according to consumer demand, how long they want or how उसको चाहिए, that is the things are. Okay. Rapid elasticity, you can assume that this is scalability. So capability can be rapidly and elasticity provisionally, in some cases automatically to quit scale out. Whenever you have to integrate more devices, you can easily scale out. You have to remove some devices, you require particular kind of capability. So rapidly releasing to quickly scalable in. Okay. The major service, and once we have acquired the service, they will charge on the cloud. So that is, you can also analyze how long you have used, what bandwidth you are using, what capacity you are using, these things. So cloud system automatically control and optimize resource use by the leveling a metering capability at some level of abstraction. They are monitoring each and every action which you are performing on the cloud. So you have seen 5 benefits. One is on-demand service, broader network access. We are allowing to different device to connect with me. Then we have seen resource pooling. The resource can be utilized by different people. So some resources utilizing whenever it is free can be pooled wide. We have capability of scaling easily, and then major service so that we can take some optimizing. So benefit from the clouds, what benefits cloud is offering. So for end user and individual, uh, we have very less amount of computing power, so we can get the cloud by which we can perform the high computing power facilities. It's improve our performance. Okay, because at cloud you have high processing capabilities. Okay, you can immediately upload and download. You can get the access of free software from there. These are device independent. Any device can connect with this one. You can download. Mobility is also there. Wherever you are, suppose you are in right now in Gopishwan, sometime after that you move in the Gopal. So that time, whatever you will able to access the service easily. Okay, it is not that constant location, geographical location constant is there. Those cloud is placed somewhere, but service is available at. For the market and enterprise, they can use the overall expenditure cost of purchasing the high-end computer system processor. They can take the service of the cloud. They can improve your business agilities. Okay, they can enhance their performance skills, specialization, all sort of things they can do. The different training program also available on this. These are very fast deployable and continuous service delivery. All the times the service is available to you. So cloud overall cloud computing structure is like this. You have computer, data consumer. We are at this end. We are requesting particular service or either uploading data. We are getting acknowledgement or either particular service is getting downloaded at our, okay, and the data is somewhere it is going to, because data could be structured and unstructured data. So data is going to store somewhere. Okay, data producer. So we have privacy concern here. Okay, and obstacle for cloud computing in IoT is the privacy protection. Okay, and second is data quantity too large. Transportation is becoming the bottleneck. Okay, so these are the problems with the cloud things. Then emerging technology on the over the cloud is mobile computing, Internet of Things, augmented reality. Inside Internet of Things, we have smart home, smart light, smart TV, robot working, all sorts. So now let us see the how computing works. So cloud is a centralized system here. The end user is here. These are the devices, whether it is your tab is there, laptop is there, any other, whether this TV and something is here. So you are always hiring some service from the cloud. Okay. But in between, we have introduced one more layer fog, which is like it is as closer to Earth. Fog is more closer compared to the cloud. Okay. So the fog is that they have different distributed nodes, computing nodes. So this time you are not relying on cloud for doing all computing node. Only the fog is concerned for whatever service is fog required. Okay, so there is layer between fog cloud network service in which fog require any service from cloud they are hiring, but the end user is only performing their computation on the fog node. These are the as computing also we can consider. The fog edges are there from where you are doing your look. You can see that you have localized system, local system, and that service you are provided by the particular vendor. You are performing your small computation and you are getting result back there on. No need to go for the cloud. If service is high, the computation is high. In this case, you will go to cloud. So cloud computing service, you check what are service they are providing. Then we'll see that how we can integrate with the cloud computing. So cloud computation technology provide basically three type of service. One is IaaS, PaaS, and SaaS. ESS, infrastructure as a service, platform as a service, and software. Now, at the time, software is also very costly resource. Okay, so software is also a resource, so we can provide as a service. So in software as a service, end user is the client, and the software in the sense you can have a particular operating system you want to run Python codes. So you can go for some compiler, online compiler. You can go for GitHub where we are represented. So you have OS, package software, application stack, server, storage, network. Inside SaaS, software as a method for delivering software application over the internet. So on demand, typically subscription based, like we are charging for subscription, particular utility you are subscribing, like you require the computation of weather reports. You can subscribe. Okay, you can see the news reports also. So ready-made software tailored to the variety of business needs. So already software is available. You just need to take and analyze your health report also. You can see. In case of PaaS platform as a service, so it is supply on demand environment for developing, testing, delivery. Suppose you want to develop some software. In this case, you can hire different services. Okay. So a deployment platform in which tool and component for creating, testing, launching application is provided by, like Tinkercad I told you. In case Tinkercad, they are providing you the Arduino board, different sensors. You can integrate, create, and design your module, upload their module, and you can utilize it. The infrastructure is service. A remote data sensor with the remote center with the resource such as data storage capability. You want to store your data over there. Your Gmail data is storing somewhere. Okay, processing power you require. You have to execute the heavy course. That time you can hire the processing power, what memory requirement, what processor, and network. So this is also referred as redundant infrastructure. So these three services are provided by the cloud. One is infrastructure as a service, in which we are getting infrastructure to storage for processing or for networking. Okay. Another is platform as a service, in which we are getting the platform simulator, in which you can design your own code and module and this. Then you can. Then software as a service. This is the last over the internet demand-based subscription. You just taking this is software and you are analyzing your code and then go. So the cloud solution, which is like you can see that mobile application, database, hybrid cloud, public cloud, private cloud. We have server, storage, and mobile. Okay. So there is category of cloud also private, public. So some see the some pros of the cloud, and then we'll see the cons of the cloud. So since connected device has limited storage capability, the device which we are using, mobile phone or laptop or tab and ComTem, your dedicated computer system, they have very limited storage capacity, as well as they have limited processing power. They have very limited RAM. Okay, the integration with cloud come to the assist in the various benefits. It's improved performance because you are getting the higher computing facilities. The communication between IoT sensor and data processing system is faster. Okay, because IoT devices are small. So when you are integrating with the cloud, we are getting very fast computing power, very high volume of data storage. You are getting storage capability, highly scalable, unlimited storage space are available to integrate, aggregate, or share and the enormous amount of data. Enormous amount of data. Any huge volume of data you can share with the your peer and the groups and integrate. Okay. Processing capabilities. Remotely, you can access the processing virtual tools, augmented reality softwares, simulators are there in which you can do. Ultimately, it is reducing costs. So you don't have to build your own infrastructure at your end and your institute. Better let us hire the service of cloud. So license fees are lower than the cost of on permission equipment. Suppose you have to build your server here, big server. It will cost around 10 lakh, but license fees to get from a cloud to access such server is only for 2,000 or few lakhs. The cons of cloud computing for the IoTs, that means disadvantage. So unfortunately, there is nothing immaculate. Okay, nothing is permanent. Cloud technology has some downside also, especially for the Internet of Things services. First is high latency. So as you know that that cloud server is placed very few far distance, like suppose in USA or somewhere, right? So obviously you are sending data and getting them, so you have huge latencies. More and more IoT apps require daily low latencies because immediately in real-time scenario you require quick response. But the cloud cannot guarantee it because of distance between. Maybe cloud server is down for, as you see that Facebook or WhatsApp was down for one day. So this is happening. Client devices and data processing can. In this case, if you have local data, suppose we have kept our stewed data on cloud and cloud server is down. In this case, what will happen for a day or 2 days, we will not able to access the data. Those convocation is going and today's convocation, I need to access all the mass detail of students who has successfully passed out. So that's that kind of error is coming. That is downtime. Technical issue and interrupt in the network may occur. Maybe there is heavy flood, heavy storm. Due to this, infrastructure has disturbed. For any reason in internet-based system, make consumers suffer from the outage. Any company use multiple connection channel with automated flavor to avoid problem like duplicate servers is they have by which you can do. The another concern is security and privacy. Your private data is transferred through global connected channel alongside the thousands of gigabytes of other users. Your data is piggybacking with the other people data and it is transferred through the global connection. So no surprise that the system is vulnerable to the cyber attackers which are continuously trying to access your data. Okay, it may be lead for the data loss. The problem can be partially solved with the help of hybrid and private cloud. So either you hire a private cloud or either you can go for hybrid cloud, which I discussed here. Public cloud, which is very vulnerable for the attackers, cyber attackers. We have private cloud. You can take high cost, you pay, you can get this. Now, coming on that term of computing, which is enabling the edge computing. And today I will show that how you can perform the human activity recognition or using as edge computing device where itself a Arduino board will utilize to capture the data and to process the data, okay, to provide the solution. Once we have captured the data and we have built the model also can be fused over that Arduino boards, and then same model is utilizing for the capturing data and processing. So it is enabling the edge computing model. So let us see the term of fog computing or fog. That the term fog computing and fogging was coined by the Cisco in 2014. It is quite later after cloud. Cloud was invented into now. So it is new for the general people, though it is quite 7 year old for the industry. Fog and cloud computing are interconnected because fog is also taking service from the cloud. In nature, fog is closer to the earth than cloud. So in this technology world, we can take refer some analogy where you have uh, end user, then in between you have fog layer, then you have cloud layer. So basic computing, which is very low power and things you can perform in cloud. Sorry, fog. And if you have high end application, so you can go for cloud. It is just fog is closer to the end user, bring cloud capability down to the ground. Okay. So fog is an intelligent gateway. Somewhere you will utilize as a gateway, network gateway. Router also considered as a fog device. Okay. Sometimes networks, all sort of things are considered as a fog devices. So fog is an intelligent gateway that offload cloud, enabling more efficient data storage processing. Same thing what cloud was providing the facility for data storage processing analysis. Same facility can be provided by the fog, but they are local server kind of things. They are keeping in the nearby the geographical location. Like suppose you have in Delhi with the centralized system. Suppose in near to Bhopal you have another server that is considered fog unit or edge device. So there is another approach to data processing similar to fog computing is edge computing, and nowadays it has become quite trendy kind of things in which device has itself has capability to capture the data, process and store the data and give the results. The essence is that data is processed directly on the device without sending it to other node or data center. Okay, so device will itself will do. So edge computing especially benefit for IoT project because it provides bandwidth saving. Because when you are transmitting data, you are consuming the bandwidth. So maybe many times you are chalk out the bandwidth service. You will have packet loss also when you are transferring data from one end to another. Generally, we are considering that that is very reliable channel, but still it is chance of possibility of loss. Another important concept which as computing device is dealing that is data security because it is on the device itself keeping the data. We are not transmitting any globally anywhere or over the internet. So that's all. So you can see the difference between the same solution I provide. IoT data processing in the cloud. So data cloud is basic computing process available here. Different devices are connected. So the definition may sound like that. Fog is the extension of cloud computing that consists of multiple edge networks. So in fog computing, what is device is there? In between, you have small networks that is we call these are edge nodes. These nodes are considered edge nodes, and that is enabled the cloud computing. So they have also some benefit of fog computing and cloud. They have loss also of fog computing. The fogging approach has many benefits for the Internet of Things devices, big data, and real-time analytics. Some advantages are listed here. First is low latency. So now you don't need to send the data over the cloud. You're sending on the local server. So fog is geographically closer to the user. It's able to provide instant responses. You can easily go and repair the things also. No problem with the bandwidth. Piece of information are aggregated at different point instead of sending together to ones because to upload data on the cloud you have to send all data together to there. Instead we have to send a small piece of data together at the different pieces sending instead. Okay. Loss of connection is impossible because it is like local device which you are continuously monitoring. So due to the multiple interconnection channel, the loss of connection is impossible, almost not possible. High security because data is processed by the huge number of nodes in the complex distributed system. So everywhere you have certain security checks you are able to identify. Improve user experience. Instance response, no downtime, satisfy user. The power efficiencies compared to the cloud because edge nodes running with the very low power devices are there and they are working through the protocols such as Bluetooth, Zigbee, and Z-Wave. They are not using Wi-Fi and some router which require high processing capabilities, which is some drawbacks of the fog computing, or you can say disadvantage. The technology does not have any apparent disadvantage, but some shortcoming can be named. A more complicated system because number of nodes you are increasing, number of edge networks you have designed. So fog is additional layer in the data processing and storage. Additional expenses to maintain these local edge devices, routers, hub, and gateways. Okay, all these are intelligent devices, so they will consider edge devices. Limited scalability, fog is not scalable as cloud. You can see the difference between fog and cloud. So if you see that architecture, cloud is centralized architecture, fog is distributed because different units you have designed for different utilities. Okay, communication with the device, cloud is very far you are communicating, but in case of directly from the edge node you are communicating. Data processing, far from the source of the information and closer to the source of information in case of fog. In terms of computing capability, if you see that cloud has higher computing capability compared to the fog, but fog is especially designed to low power computing. Number of nodes is in cloud is few, but fog you are a very large number. Analysis purpose you can use in cloud for long term. You can store the data, but in fog we are keeping for the latency. Cloud highs and low connectivity through internet and here various protocol and standard. Security is lower very in cloud and whereas in fog you have higher. So you have seen the difference between cloud and fog computing. Now I'm coming on the another computing paradigm which enable your fog computing, that is edge computing device, edge computing device. So these devices are only enabling your IoT device to build the fog computing. So fog computing, what is happening? You have a cloud over network here. You have designed your some concepts here, okay, and then you are going to do this. So what is computing here? Network architecture, computing, processing, and storage resources. Okay. So we have to do some computation. We can take the computing. We have to process particular information we can do, and we have to store something. So in case of edge computing, what is happening? The network architecture, whatever cloud was providing, the these devices, these network devices or edge devices, which we can refer, providing the computing, processing, and storage resource capabilities. These devices all are interconnected. So place as the end of network or edge of internet. Whether in term of internet, you are placing on the edge of internet or network. So these capabilities, computing, processing, and resources. Geographical very closer to device, you can say the device. So layer 1 is considered the IoT plus sensors, layer 2 is the considered as edge node, layer 3 is considered as the cloud service. So geographical very close to device, computation and storage very close to the device, minimize long distance communications. You don't need to send your data for long distance. Then latency and other issue will not encounter those limited processing power. Distribute part of cloud server data processing workload. So whatever processing you are doing in the cloud add together. Yeah, any question? Some noise is coming. I request. Doctor, I'm Santi Mungram. So distributed part of cloud servers data processing workload. So cloud server as it together single package we are um, processing the data. In this case, what we have distributed the service over different edge node or edge network so that they can provide. So integrated on the localized computer. It is reducing the overhead of cloud. So you can see the diagram also. In centralized application running different whether it is Arduino Nano boards or some you have camera sensors, you have traffic light monitoring, all are controlled through these cloud services and cloud services are provided to different. You are directly into. In case of edge computing, the computation is also enabled on these nodes, these network nodes. Okay, so centralized application run closer to you, use either on device itself or network edges. Okay, these devices are capable for computation. Here computation is taking place at the cloud. Here computation is taking place on the these devices. That is what edge computing. Okay. You have sensor, controller, actuator, all these ends. You have proximity sensors. You have then gateway to connect with the edge or OG devices, and then you have cloud. So this is internet within building or your geographical region, that is over internet cloud. We have different IoT gateways. Then you have server, network switch, and storage. So edge is real-time data processing when you require fast computation there. Real-time control machine to machine. Local data filtering and the caching also we are doing. We are filtering the local data as well as we are keeping for the long time. And the source data visualization you can see. In the cloud, this is central processing of the summary of data, big data analytics, complex learning model, and center control. So they have internet over as computer is working and internet working is on the cloud. So IoT is infrastructure involves IoT gateway is controller on promise. We have server, network switch, and storage, and then we have internet gateway by which we are. So it is quite fuzzy term. Edge computing. Okay. So edge device is outside the data points. There is network edge, that is device or local network containing the device communication with the internet. And the edge servers immediately between the network and the cloud it is coming. The takeaway of these things is to the network that is geographical to the network and the cloud very far from the device. So number of wide variety of application of edge computing of product and service are in security system monitoring. Okay, defense application. Many where you can use. Self-driving car is also example of edge computing in which the car is enabled with all basic sort of processing. They have sensors to sense data and they are taking whether they have to stop machine, they have to download. In defense area also, what you have to do if you require certain kind of information processing or some uh, cloud robotics kind of application in which you can download the data from the cloud to the machine to enable with particular capabilities. Okay, if hiring is happening, some programming capability also, computing capabilities, some data storage you can do. Some crash of aeroplane has happened, you have to store this data over the cloud. So immediately the sensors are there. When they are assuming that it is like crash of aeroplanes, they will immediately send the data over cloud. Medical monitoring devices like telemedicine, teleconsultation, you can see that from remote machine. IoT device, video conferencing also is the case of edge computing. So military and industrial applications like where soldier wearable device, battlefield systems, offshore oil rings. These are the user case of edge computing, which is part of IoT device. So the benefits you can see in terms of lower latency, security, bandwidth, and lower cost. So because they are very near to us, less distance, reduce processing delay, and improve our response time, fast processing we have. The bandwidth usage will also less because you are not sending huge volume of data. Storage and processor at the edge. So we are storing data and processing at the edge. We are not sending over the cloud. So obviously it is cutting down the amount of data being transferred from one end to another end, and it is reducing the bandwidth network bandwidth. If network bandwidth is less, so obviously the cost is also going to cut down and improve security and reliability, data storage and processing. So decentralized to edge devices, ramification of the security breach. It reduces the chance of security breach, okay, and maintenance state. So unnecessary delay is not happening when you are waiting for your service. Secondly, cyber attacker and regular maintenance. So these devices are isolated. The edge devices are isolated, so they are not that much vulnerable to attack by the cyber attackers, which are continuously monitoring the device over the internet. So the cyber attacker, you can avoid this chance of attack. High speed, reduce latency, better reliability, save time and resource, optimize performance because particular computing power you are performing on particular local server, security and scalability. Some disadvantage of all computing, more storage capabilities required. Cost of the designing of these edge computing high, depend on the application. Sophisticated algorithm better handle the cloud because the cloud has much better capabilities of dealing with them. Simple analytical process is best to deal with the edge. Okay, security challenge also that if number of application is increasing, so number of chance of attacker vendors is happening. So now I'm coming on what is IoT edge. Okay, so IoT is that move cloud analytics and custom business. Whatever I was getting service from the cloud, I have moved on the edge devices, process and relevant cloud software to your IoT device. So if IoT device can itself do the data processing of data collected through that device, then I can say that it is considered IoT edge and it is providing like cloud service. The impractical concept is that upload collected data to cloud for processing and analysis. That is quite impractical. It is small whether today weather data or soil data I am collecting through IoT device. It is impractical to send over the cloud and process. IoT is networks free from the need to upload device data to the cloud, and they use to run cloud functionality on our IoT device. So they have very less interaction with the cloud. So that's why lightweight interaction. And we have machine learning. Only for machine learning purpose we are doing cloud service. Otherwise, every other data processing we are doing in the IoT agents. So IoT is run cloud-based IoT and the AI-related software offline. The key element of IoT is are three: IoT edge modules, IoT edge runtime, and cloud-based interface. Cloud-based interface, IoT edge module, IoT edge runtime. So IoT edge module is that especially it is deployed to IoT edge devices, execute locally on the device. Okay. The IoT edge runtime you require particular service, so manage module and deployments. Okay. And then cloud-based infrastructure remotely monitor and manage IoT. So one by one we'll see that IoT edge module. So unit of execution implementation is a Docker capability container. Run the business logic at the edge. So only we are running the business logic or some capability on the edge. We have multiple modules. They are communicating with each other. So pipelining of data, so parallel processing is happening. Software performing the data processing. Okay, service provider, third party apps are there. The operating system they are supporting Linux, Windows, Java platform, programming language, .NET Core 2 or Python C they can use. So IoT is the object is that deploy complex event processing, machine learning, image recognition, other high-end value of AI without writing. It is in-house. That means I'm not writing any code. I'm getting this service from IoT Edge to do machine learning, to code execution, image recognition, other high-end AI utilities. Then IoT as runtime. What is happening? As you can say that IoT is runtime is there. They have module, telemetry operation, insights, action you have to take. So they are performing the functionality like monitoring, managing, and the facilitating communication. This is runtime. They are monitoring devices, they are managing and facilitating communication. They are supporting the Unix as well as Windows Office. And they perform the functions which are here. Store and upload workload on the device. So if you have any workload on the device, they help them. Maintain IoT security standard on device. So they have to maintain the whatever IoT edge security standard on device. Ensure the IoT edge module are always running, they are not closing. So these are all runtime module of IoT's edge is looking. Report module health to the cloud for the remote monitoring. Okay. And then we are managing communication between IoT devices also. So what we have done here, we have deployed the AI capability over the gateway edge, okay, to process or aggregate it. Now I'm coming on the cloud-based interface, which cloud was providing. Same interface we can provide by the edge devices. Okay. So what is there? They workloads, create and configure, deploy, monitoring. They have to deploy as well as monitor. So they are control center for IoT edge device. Okay. Whatever IoT edge device are working, they have control center. And it integrate the IoT solution, escalate the control panels. Okay, the cloud services allow you to create and configure workload. Suppose you have high end of workloads, you can distribute and configure over these things to a specific device. Send a workload to the set of device. Monitor workload running on the device in the fields. Okay, in the fields, if you are getting any workload like John are capturing the data, so they are communicating with particular IoT edge device. So the gateway, there is two kind of gateway by which IoT edge devices communicate. One is transparent, another is translation. Transparent when device is directly constrained. Transparent and the translation gateway patterns are not mutually exclusive. There is no common. IoT edge devices function as both transparent as well as translation. Now let us see what is transparent gateway. So in device connected to gateway device instead of IoT hub. Okay, they are directly getting to gateway like router and switch. Okay, and downstream device on IoT hub identities. They have IoT hub identity and connect with the MAQT, AMQP protocols. They used to support, but in uh, second method, which is translation, they are not supporting. So gateway passes communication between the device to the IoT. So there is IoT hub, there is gateway, and there is devices. So there is three layer of architecture. So both device and user interacting, we are unaware. But in translation gateway, it acts as a translator and require device to they do not support MQTT, AMQP, HTTP protocols. So that's why we require to do some a little bit processing, pre-processing things. Okay, and the translate module translating incoming message from the format understood by the IoT. So there is two things which we have to do in the translation gateway. One is protocol translation and identity translation. So protocol translation, they used to receive the message from the downstream devices and they translate into the supporting protocol by the your IoT hub. IoT edge devices send message on behalf of the downstreaming devices. Okay, this device itself will reply. That is gateway. Downstream devices enable additional identity information analyzed databases. IoT hub permits support for the gateway devices, non-downstream devices. Okay. Another is identity translation. One is that cloud protocol translation, another is identity. If device cannot connect with the IoT hub, connect to the gateway device. Gateway understand the protocol and the downstream devices and provide identity and identify translation gateway pattern, which a particular gateway is dealing with this one, and perform the protocol translation. IoT edge gateway provide the IoT hub device identity behalf of the downstream device. So uh, here I introduce what is IoT edge module. There is IoT edge module, there is IoT runtime module, there is cloud service interface. Then you have uh, gateways two kind. One is transparent, another is translation based gateway. Transparent when directly communicating with the IoT hub. Translation when you require intermediate three things. Then there is two things: protocol translation and identity translation is come. So in short, you can see the protocol translation and identity translation difference is there. Okay. So identity stored in the IoT hub. There is IoT hub identity registry. So only the identity of gateway device in the protocol translation, but wherein in identity register, all concerned devices registers. Okay. Their registry is there. In case of protocol, we only seeing the gateway. Device twins, only the gateway has device and module twins. And in this case, each connected device has its own. So in case of identity, each connected device has to maintain the things. In case of this one, only protocol that IT gateway is doing to. So the gateway patterns has benefits like edge analytics. Now new term after edge computing there is edge analytics. So what is that? They are providing SAM service which was cloud was providing. This is AI service. Subset of data is sent on the IoT hub. Okay. Downstream isolation so that no security breach is there. Connection multiplexing. Multiple people can connect. Okay. Traffic smoothing, limited bandwidth, and this is. So now let us see the difference between edge computing between edge analytics. So they are not mutually exclusive. Somewhere they are sending two sides of same coins. You can check. So cloud, that is big data processing, business logic, and data warehouse is there. Business logic means some software module or intelligence is there. Edge computing, that is real-time data processing they are doing at source on premises inside campus. Data visualization capabilities edge is providing basic analytics, which is we call edge analytics. Data catching, they are storing, buffering, data filtering, they are providing optimization, machine to machine communication using. And below this, we are coming an IoT device which is inbuilt with sensor and control. So if you see the difference between edge computing and edge analytics, it is there. So edge computing just data collection and data processing performed near the location where the data created or consumed. It is near to that computer device. Whereas an edge analytics use same device. That means IoT device itself data already produced, analytical model performed. That is mean as and same device is capturing data and doing analytics part also. In edge computing, use device to act a computer to log event, perform inter-device communication, track location. It leverages same device or device utilization, process data that has been computed and turn into the automatic actionable information right on. So no need to keep the location information log. As computing perform analytical function, and as analytics perform descriptive or predictive analytics. In case of things we are going to directly inbuilt with models. So what edge analytics is delivering? Edge analytics involves creating an analytics models, deploying the model, executing the model as the edge. Decisions are made with respect to collected data, preparing data, selecting the algorithm, which algorithm you have to do, training those algorithms, deploying and deployment mode could be centralized or peer-to-peer deployment. So now coming on the benefits of deploying edge analytics. Okay, first is industrial IoT, IIoT. Robotics IoT is there. So industrial IoT, Internet of Things, in which this edge analytics is playing crucial role. So how it is doing? Segment deploying edge analytics like retail, manufacturing, energy sector, smart cities, transportation, and the logistic where these kind of processing is required. Specific use cases are retail customer behavior analysis. We have to see that the customer is coming this particular product they are purchasing in this. Remote monitoring and maintaining of energy operation in the particular plants and somewhere. Fraud detection and the financial location. Monitoring and manufacturing logistic equipments. Other fields, customer engagement analysis, online banking, remote control. These all are coming on under industrial IoT. Another edge computing is very important edge analytics in education domain. So providing the AI videos based analytics. We have a choice which particular video we can see, which particular video is more beneficial. Transform teaching learning process. So recently Sony has designed a AI enabled edge analytical based solution, creating video content. For creating video content, Sony has devices this AI edge analytical based solution. So some application handwrite extraction, gesture recognition, focus cropping, audio trapping. Another is healthcare, which is evolving, and the today afternoon when I will discuss about IoT as a healthcare device. That I am going to discuss how human motion, human walking can be utilized for to trace the health monitoring of human being. So all the times like the band you are wearing, you are monitoring your heartbeats, your pulse rates, your things. So you are all the time connected with edge devices computing, collecting data, and giving out. So in healthcare, IoT profound impact on the industrial play. Nowadays, what is happening during COVID? So it is very susceptible that person is not directly interacting, doctor is not interacting, they are not available. So teleoperation, telemedicine, teleconsultation is happening. You have body area network. Maybe you have heard about yesterday wireless body area network in which what is happening, the different sensors are placed over the body of human being, ECG, EEG, EMG, and they are continuously monitoring from the far end. Doctor, if any, suppose the patient is sitting on the bed or sleeping on the bed and no one is there, his heartbeat is getting down. In this case, what will happen as heartbeat will go down, automatically alarm will generate and concerned supporting person or nurse will reach to there immediately to protect this. Okay. So IoT has profound impact on the industry as well as healthcare, as well as education, as well as uh, smart city projects, which is coming under industrial applications. So deployment of application, patients status monitoring, diagnosis monitoring, monitoring of their temperature, moisture, UV radiation in the medical product storage, analysis of environment condition, what impact is there. So hospital is almost, they have given example of, they have connected with 85,000 connected devices over the cloud network. So Edge analytics provide us the optimal methods, it's eliminate overhead, address storage, securities, connectivity issue, and the cost effective ways to dealing with it. The innovation technology are the healthcare, which is quite in. That's why my talk will related to healthcare only, uh, in which we'll see that how wearable and other devices computer vision based techniques can be utilized to monitor the human health, to check their things. Now different IoT devices design which can check your hemoglobin level also. Uh, that is non-invasive, in which you don't have to take blood sample. That's you place there, like temperature reading. You place your finger over there. They will capture whether you are suffering with anemia because the hemoglobin level is very less. This kind of things are there. Other application of edge analytics: optimal model managing data transfer from the edge, smart data storage for data centers, advanced analytical methods. We have to predict, like in weather forecasting or traffic monitoring. Traffic, we have to predict where we have to go. So predict failure of the system component, maintain functionality of device, and smooth work. So edge analytics design the smart machine, which is self-responsible action and the predictive outcome. So retail, manufacture, energy, logistic, as analytics everywhere. They are designing the business benefits, reducing the latency of the scaling out the analytical resources, and solving the bandwidth limits, and reducing the expenses. Okay. Then another term is coming, big data. After cloud, so big data is that the data which is stored on the cloud is, it is big data. So Hadoop, Spark, Kafka, all sort of things. So big data analytics is the process of examining large and the variety of data set. That means huge volume of data to uncover the hidden pattern over there, because the data is mostly we are capturing is design structure. So whatever pattern is available that we are extracting, the correlation was unknown to us. The market trend, customer preference, and other useful information can be extracted through these prediction. So suppose data is available unstructured, we'll find the pattern at which time the peak hour of selling particular product, when people are purchasing more, when people are hiring particular service. Okay, so useful information can be extract the optimized information. I request some sound is coming. Hmm. So big data is helping us to process the high volume as well as variety of data to find the uncover patterns, give the some optimize or some beneficial or business oriented outputs. We can see market trend, customer preference. So big data analytics deal with the things where you have to cost reduction is required, fast and better decision making decision is required, and new product and service are each time is coming you have to integrate. So a lot of data is being collected in the warehouse, okay, through in form of web database, e-commerce data, okay, purchase at department, grocery store, bank, credit card, and transaction and detail, social networking data. So this is huge volume of data from where we can gather. Variety include different type of data like structured data, unstructured data, semi-structured data, all of above. Apart from their velocity, because 4B is there: volume, variety, velocity, and this. So velocity refer to the speed at which data is processed, like in real-time system, batch processing, ST streams. Volume refer to the amount of data, so there is no limit. You can have terabytes, record, transition files, and data. So later on, big data, cloud computing, fog computing, you can integrate. While it seems that these two concepts are similar, they are entirely different. So now you see the difference between cloud and also big data. So cloud, what is it? It is providing us resource, software as a service, infrastructure as a service. Okay, platform as a service, storage, computing, database, monitoring tool, etc. on demand. Whereas big data provide a way to handle the huge volume of data and generated insights. They are just not storing data; they are giving some fruitful information. Reference is referred to the internet service from SaaS, PaaS, and IaaS. Okay. Internet service. It refers to data which can be structured, semi-structured, and structured. How they are using. It uses a wide range of network cloud server over the internet to analyze data information. Big data, it could be deployed either on premises inside your building or cloud to discover the undiscovered pattern. So job is to discover the pattern where it is storing. You can place anywhere, like in fog computing on premises. Okay, format cloud computing is no parallel to cloud resources, whereas big data it consists all kind of data which are in many different formats. It's used to store data and information on the remote server in the cloud computing, whereas in big data it used to describe the huge volume of data. So now I'm coming some papers which you can refer. Those I have mixed with my talk, and you can refer some papers related to IoT. I have also smart that IoT paper I will tell you. Smart health monitoring I will start late in the second half. You can refer this paper, implement this. Okay. Connecting this flow connection of Internet of Things with human social domain specific knowledge. This is one paper. This is visual sharing. This is another interesting application which I am going to discuss with you. Ah, this is third. Advanced automated module for the smart and the secure city. You can refer this paper. Another paper is that this is related to this flow connection. And the third one, which I'm going to discuss, is marriage and the viewer sentiment improve the quality of film and interactive usage. Okay, IPv4 and all. First, I'm coming on this paper, which is published in the Procedure Technique. That is advanced automatic module for smart and the secure city. Okay. So in this case, ICT. Okay, information and communication technology was evolved, and we have discussed about the technology overview, the module of power thefts, especially how people are, how you can avoid the power thefts. So we are monitoring that, and the people are not paying money for the, they are consuming electricity. Okay, so such module was designed. So this day, when emerging deployment in all sectors, growing energy demand, electricity has become the priority to every individual. So that's why it is required to save. In case of Indian scenario, we have said we have designed one app also. Okay. So working with the VI modules to power theft monitoring system, we have seen that where it is happening. Different hardware module was applied, IoT, Bluetooth. These are the requirements, camera based security. So weather proofs, Ethan using camera shields was there. This is for to traffic monitoring. Advanced traffic monitoring was things. So traffic control system was live monitoring in the manual controls. You can see that when traffic light will burn, and Tinkercad also we have checked that day how traffic monitoring system was evolved, designed. Okay, some things we have utilized here. Okay, then we have provide some analytics also. Actual cost of energy sold to the consumer and return revenue. You can see that due to the power theft, how much power you are losing. You can see the house 1, 2, 3 domestic units, whole monitoring and the power. So how much power theft is here. Okay. So you can refer this paper. That is automatic monitoring system for advanced, secure, and the smart. So industrialization and urbanization especially has the attention to save the power thefts which is happening in India and to reduce the power consumption. You can see. The another popular application was DISLO, connecting the Internet of Things through the human social network with the domain specific language. That means local language. Okay. In this case, we have a smart object near us connected to the Internet. These objects could make the things together if it is easy platform exists. Okay. So there are many researchers about interconnecting smart objects. We propose a novel approach using human social networks. Okay, by seeing their connection. So even domain specific language we have searched. This approach make easier and the creation of the interconnection not only among objects but also between objects. So you can see that Arduino device, Arduino board is an actuator and sensors. This is social networking we have connected. This paper also you can refer. The last is measures viewer sentiment to improve the quality of television input, in which we have used NLP also, where we are looking for continuously seeing the feedbacks, their sentiment, how they are interacting, what is their perception about particular data. So based on there, we are changing our adaptive contents, we are updating. Okay. So this paper describes the purpose and the result obtained by the implement and the experiment to monitor the sentiment analysis against the adaptive content viewer as a live TV program. Okay, using interactive session when they are doing. So initially, it make the introduction to the login in this. So you can see in the depth what is happening. This is protocol adaptive ITV contents live. Okay, this is. So again, here I'm including this social analytics, Facebook, Twitter, these things. So opinion mining for the Twitter on the IoT device also you can use. You can refer these three papers. So light monitoring system, already I showed you smart traffic light monitoring system. This was still light already was done. Traffic light monitoring was I was discussing. You can simulate. So this time it is green. The other three are there. Once it will become yellow, so the next station is also getting yellow. These two stations is going yellow light because this is going to red and this is going to green signal. Okay, rest other are there. After that, this is green, just are red. Now it is going yellow and this is also going yellow. So now it is please be ready and we are going to close and you can start. Now it is becoming red and this is becoming yellow. Green. Now it will become yellow. This is last time and you have to start now. So this way. So the green is telling you can transfer the data. Yellow is telling two case. In case of when I was transmitting the package, that time you have to say that now you have to stop. So now you move fast because the red light is going to happen. Another time, green light is going to happen. Okay. So you can see the code also for this one. The different pins were used because total 12 LED was used. The 12 number 2 to 13 is there. All output. So at a time you are reading particular write high, just other is low. Okay, initially it is clear. So you can just change somewhere high and low. So yellow light is going to high, rest of the light is going to low with the delay of so you are waiting. Delay is telling how long you are waiting. This is okay. So then with this, I will close my session here and I will open for question answer. So if you have any question answer, you please ask. Feel free to ask question. Yes. Then 3 p.m. will come again with the human activity report. Vishwanath sir is here.
Yes, sir. Yes, sir.
Ah,
So
so I have done
participants,
with you. Yeah.
yes, sir. Yes, sir. I uh, I request to all the participants, if you have any queries, so kindly ask, because this is very important lecture, and you can feel free to ask. Participants, please ask.
You can write in chat box also. Almost 60.
You can write in
At,
chat
at
box.
least you have any queries about what is fog computing, how it is enabling edge computing, different pros and cons we have seen of cloud computing.
Sir, I want to ask a basic question.
Yes, please.
Uh, so what is the difference between cloud computing and fog computing? Because in fog computing, we are also using the cloud, but
Ah,
there is some middle layer like fog in the fog computing.
so very good question,
Okay.
and the question is very, very. I think that the question we should ask from the participant is asking from organizer. The question, the difference is that cloud computing, the device itself is directly connecting with cloud. There is no intermediate layers or link. Okay. So IoT device is directly connecting on cloud. So the small service, if you are looking for there, then also we have to go for cloud. So cloud is especially using for storing resources, performing computation, getting some services, these things. Okay, suppose you have to just monitor the health. The IoT devices capture data and you are sending on the cloud and then it is giving you. In case of edge, what is happening? I'm distributing, I'm reducing the overhead of cloud. In between, I have added one more network node, that is edge node. Okay, so for computing, what is happening? Most of the computing you are doing at the edge computing. For computing, you are not going for cloud all the time. Cloud only you are going if your data is big data is there. You have to do for high volume of computation. Local computation you are performing on the fog. And the another benefit that fog are your local server kind of things. Cloud is your global server. So global service server can be down, but local server you can maintain easily. Local computation. Only thing that number of nodes are increasing. This term of fog nodes or as node networks. These nodes are in. So what is happening? The computation we are not performing on cloud this time. That this it is not centralized. Now it is distributed over different edges. You can take the example is there. Suppose the your license on. So all people are applying for license. So suppose centralized database in or cloud in the data, Delhi. So it is generating the license number. In case of edge computing, what is each unit? Suppose you are in Dehradun, so there is local server in Dehradun. So they are doing their task. They are providing license from there. Suppose I am in Bhopal, so I am getting from Bhopal region. It is not that I am directly consulting to cloud, which is available in there. Okay, and only few service I will go. So in this case, I have reduced the burden of cloud. I have reduced the latency. I have reduced the chance of data loss. Security also is there. Okay. So I hope that this will make you clear the difference between cloud and the how computing.
Yes, sir. Yes, sir. Thank you so much, sir. Wonderful answer,
Yeah,
sir.
yeah. Thank
Any
you.
any other participant who want to ask some questions? See, this is a very crucial time. Please ask. Sachin
Anyway,
Sati, sir.
you can write also in my mail if you have there. So you can ask in future. Otherwise, afternoon session I will go for human activity in which we have collaboration with the Institute of Technology Gopishwar, where we have collected dedicated lab is there to collect the human activities data for different activities for different motion. So they have motion capture lab, very good lab. So people can explore and if possible, maybe Vishwanath sir can allow to visit that lab virtually.
Yes, sir. Yes, sir.
The question was
Thank.
asked from the Path. Right. The local server in the cloud computing mean that. Acha, okay. So it is running in the internet. Yes, correct. It is running on the internet and LAN. That's why it is secure also, because it is not over the global network. Correct observation. Very good observation. Any other question?
Any other question from participants? Puneet Bansal sir, Dr. Puneet.
Okay, no problem, sir. If they have any question, they will write here also mail ID. So already,
Yes.
and yeah.
I will share your mail ID, sir, so that every participant can ask you a question personally.
And anyway, I will come in the afternoon
Yes,
around
sir.
3 p.m. for Roman motion. That time also you can ask if you have any question. We will start with the question answering session. Then we will start next session.
Okay, sir. Thank you so much. So I think there is no query from other side. So I would like to thank you, sir, for this wonderful session, and thank you for giving us your valuable time to us.
Thank you, sir. Thank you. Thank you for giving
Thank you
opportunity,
so
and
much.
it is really my honor to present my work or my learning here. Okay. Thank you.
Yes, sir.